Here in number 8, we are asked to find the absolute min and absolute max of this function on the closed interval negative pi over 2 to 0. Oops, that was a little weird. Sorry about that. So remember what we do with these problems is we need to find the function values at the endpoints. So I need f of negative pi over 2 and f of 0. And I'll get those y values. And then I'll also check for critical points. And remember, the critical points are interior to this interval here. Okay, so in the meantime, let's plug in negative pi over 2. When you do that, you get 2 times negative pi over 2, which is negative pi. The cosine of negative pi is negative 1, and negative 1 times negative 2 is positive 2. So the y value there is 2. Cosine of 0, or 2 times 0 is 0. Cosine of 0 is 1, and 1 times negative 2 is negative 2. So we've got those two y values. Now, we also need to take the derivative and check for critical points. So the derivative of negative 2 cosine 2x is going to be positive 4 sine of x. So y prime is positive 4 sine of 2x. And the way I did that is I did, oh goodness, I keep bumping that thing, negative 2 for the negative 2 constant times the sine of 2x times the derivative of 2x, which is 2. So that's, the negative sign. Derivative of cosine is negative sine. So it's positive 4 sine 2x. And what we need to do is we need to find out when this thing equals 0. So I have to solve this equation. And I'm only concerned with places where it equals 0 in this interval. So I divide by 4 and I get 0. So sine of 2x equals 0. And then the solution to this is 2x equals inverse sine of 0. And I'm looking for places in the interval from negative pi over 2 to 0 where the sine is 0. And by that I mean we are looking for values of x that fall in this interval. So let's talk about what the inverse sine of 0 really is. The inverse sine function returns angles to us that have a sine of 0. So those angles are things like 0, pi, 2 pi, and also negative pi and negative 2 pi. So any one of these angles might produce an x value that's in our interval. So essentially what we have to do to solve this thing is we have to divide all of these suckers by 2, right? To solve for x, we divide by 2. So 0 divided by 2 is 0. Pi divided by 2 is pi over 2. That doesn't fall in our interval. 2 pi divided by 2 is pi. That doesn't fall in our interval. Negative pi divided by 2 does fall in our interval. And negative 2 pi divided by 2 is negative pi. It does not fall in our interval. So the critical points that we produce when we solve this thing are actually the same as our endpoints. So you do have to go through this process. My guess is that the reason this question came up is because people did not know how to solve this equation. And I'm reminding you from trig class how you solve it. You do the inverse trig function. And remember that the inverse function, the inverse of sine, returns an infinite number of angles. And we have to check all of them to see which ones fall in our domain, in our interval. And these were the only two that fell in our interval. Now, once you determine that you've got all your endpoints and critical points calculated, your job is simply to pick the highest and the lowest. So when I look at this list, all I have is 2 and negative 2. 2 is the max, and negative 2 is the min, right? It's the lowest. So when you answer the question, the absolute max is positive 2, and the absolute min is negative 2. And that's what we were asked to find, and now we've done that. Okay, now just to see if we're right, let's graph this thing and find out what the highest and lowest values are on our interval. Let me show you what I mean. So if I bring up decimals and I type in my function, which was y equals, hold on a minute here, y equals negative 2 cosine, and to get to cosine you hit functions. There's cosine, 2x, close the parentheses. And remember, we want to limit that from negative pi over 2 to 0. So we do negative pi divided by 2 less than or equal to, make sure that, darn it. There we go, less than or equal to x less than or equal to 0. And then close off our brackets. And this is the function here. And notice the highest point on this graph is right here, and the lowest point is right here. For this interval, the maximum value is 2. We had it right. And for that interval, the minimum value is negative 2. So this brings a picture to the math that we're trying to compute when we do the extreme value theorem and we check the endpoints and the critical points. Basically, what we're shown here is there are no critical points in this interval. This thing's only decreasing. It starts at 2 and it goes down to negative 2. When we say critical points, remember, we mean things that look like this, or corners, so something like this, or cusps that look like this, right? Or vertical tangents. So if we had one of these pictures, those would be critical points. This picture has no critical points. It was just the endpoints. And the math that we wrote on the last slide showed that. I'm just showing you this picture to give you some reinforcement and help you gain confidence in what the math that you did was. That was not English. To get confidence in your computations. Okay, that's enough for this video. This was number 8. If you need anything, you know where to find me. In the meantime, take care.